So welcome, especially. So for this roundtable, so we heard a lot of interesting things about weather forecasting satellite data, and now we will discuss how it will evolve in the next 10 years. And yeah, first we start with Paolo RUTI, and yeah, the first question is MTG1 in December, you launched 2022. And can you tell us about the data and applications, and what are the plans for EUMETSAT for the next years?
Thanks. Good. I hope it works. Good morning, everybody. So my pleasure to be here and to represent in this very distinguished panel, EUMETSAT. So as you know, together with ESA, we developed the satellite and we launched it and we operate it. Behind operations, there's a lot of things happening: science, technology, telecommunication, engineering. So it's a lot of things that EUMETSAT does. So it's important to remind everybody. So, but how is important MTG, the Meteosat third generation, is looking to the Earth, 36,000 kilometers away, as has been already explained, and is capable to detect many things. So he has a huge camera, very, very sophisticated, and he has the possibility to look to wildfires, to help us to preempt or to help emergency services to detect wildfires. It's capable to help to observe and to detect the development of storms that are becoming bigger and bigger. And we have seen how these impact the day-to-day life. We have seen recently in Germany, southern Germany. So and we have the possibility to detect lightnings. So basically, very, very tiny photons that are derived, and I think Christina showed how important into the nowcasting. So you have lighting across between clouds and within the clouds, where you can determine how fast they are growing and how dangerous they will be, those clouds. So those are elements that we are capable to detect from the Meteosat third generation. And wildfire back, as you know, there's basically, if you consider as a, let's say, conservative measure, 2023, 10 million hectares are burning with wildfires. Is a bit less than 1/3 of Germany, a bit less than half of the UK, just to give a measure that every year. And with the climate change, this has a stronger impact, even in northern latitude. So this is as an example, we are capable to detect at a resolution of 500 meters using 2 specific channels on these very, very sophisticated camera that we have on 36,000 kilometers away. And so this is a possibility that together with the other satellite data, like you are looking to the possibility also to prevent, and so to look to soil moisture, to winds, surface winds, etc., to prevent this. And you can analyze the risk, but then you have to track, and this is a huge possibility. But what will happen in 10 years? Because that's the question. I think this is the challenge here.
Good point,
So what we know today, how all those data are used. They are directly used, satellite data. They are used through models, as Jean-Noël told us. So you have weather forecast model, and nowadays, are we sure we can say what will be the operational model in 10 years' time? This is a very debatable question. And how machine learning, which is already exploiting fast the satellite data and other type of data, can accelerate the use of the data in the next 10 years is a tricky question. But there are other questions on the table. We look, when you plan a satellite, you are looking to the, first of all, from a user perspective, because we represent 30 countries, EUMETSAT, but we represent 30 big users in the society, so represented by the meteorological services. But how do you plan and you design these satellites? So you have to look from the eyes of the users. So look to specific sectors and you scrutinize all the sectors. Like, let's speak just for 1 second about aviation that has been mentioned by Christina. So in the 70s for aviation, turbulence, winds were important parameters. In 82, the first case, volcanic ash became a problem because there was a big volcano in the tropics, and the first flight that has been diverted by this because you have an engine and the blades of the engine can be affected by the volcanic ash. But nowadays you are moving further and you are speaking about drone, taxi drone between Heathrow and London City, or between Charles de Gaulle and Paris Center. So the level of the services and what the services are requiring in terms of measurements and capacity to integrate different type of data is blowing. And this is also another challenge that we have on the table. And I'm stop here.
Yeah, okay, thank you. The MTG has also is capable of visualizing the radar data. That's very is this the MTG radar? It's about
no. MTG is not about radar. We don't do radar from.
Okay, then yeah, I mean the rain. It's showing the rain.
Yes,
it's not radar, of course. Yeah,
yes.
This was a failure. Yeah, yeah. Okay, and yes, and okay. The next question were then how is ESA planning the next 10 years, Graeme?
So thank you, Özden. I just would like to give an overview of what ESA's Earth Observation Program is. I have here just a little schematic which shows some of the essential climate variables, such as sea surface temperature or mean sea level or total ozone column, which are measured from various of our satellites. And we have a tagline that we are taking the pulse of the planet. And we have a very comprehensive, I would say, Earth observation program in Europe, which is probably the envy of the world, particularly through Copernicus. And this covers a whole range of different satellites. So what we have, it's split into what we call 3 different streams here. The first there is the science, which is really looking at new satellites, exploring fundamental science of the Earth. Then there's a Copernicus, which is an operational program together with the European Union. And then our meteorological satellites. And I'm responsible for that last branch of the orange ones. And we have a huge number of satellites here, which vary from going back to the old heritage ones, where we just have the data sitting in the archives, as was mentioned earlier, which is useful in the reanalysis to be able to go back and see what happened in the past. We've got 14 satellites in operations, which doesn't include the meteorological ones, which are operated by EUMETSAT. We've got 45 satellites in development. So that is with full funding to go through to launch. Then we've got another 19 in preparation, which is in the early stages, the phase 0, phase A, phase B parts of the studies, giving a total of 84 satellites that we're talking about here. Now, most of the satellites that we launch are in the range of 1.3 to 2.3 tons, which is roughly a Volkswagen Golf to a big SUV. The ones here, some of the ones we've got, are the biggest ones that we do. So Meteosat 3rd generation, it actually comes in 2 flavors. The first is an imager satellite, which was the first one to be launched in December 22, which contains embarks this flexible combined imager, which is giving really fantastic images of high quality resolution and in many more spectral bands than before, plus the lightning imager. That one comes in at about 3.8 tons, so it's a medium minibus. Then we have the METOP second generation. This is to build on the first generation of METOP, which are currently in orbit and are actually the single most important series of satellites for numerical weather prediction. And we aim to maintain that for the second generation and even expand it. So it is now going to come in two flavors. It's going to come with this A satellite and the B satellite series. There's 3 in each series. And those are coming in at about 4.5 tons, so a large minibus. And there's 10 different instruments across those 2 satellites. So it's going to have a real impact on NWP. Then we have the Arctic Weather Satellite, which is a new space development we've done. This is the smallest satellite we have. It's about the size of a small fridge, 120 kilos. And it's a passive microwave radiometer. And that is due to be launched in a couple of weeks, beginning of July, on a Falcon 9 rideshare. And this is very important for us because this is paving the way, we hope, for a constellation of such satellites, which EUMETSAT will fund, called EPS Sterna, which will have 6 of these in orbit at any one time, and will really have a big impact on the temporal measurements that we've got for passive microwave sounding. So I would not like to just focus on the meteorological ones, but also on Copernicus, in particular, what we've got coming up in the next few years. It was already mentioned, and I think this diagram was already shown, with the expansion sentinels that we've got coming up. So there's 6 of these. And the way to read this diagram is really to start at the center. And you see the areas that each of these satellites collectively will look at. So from contributing to climate change, to not contributing, monitoring it, but contributing to the protection of it. In particular, the CO2M mission, which is looking at anthropogenic carbon dioxide. Then food security and water management, monitoring land and natural resources, and safeguarding the Arctic. And you will see for each of the satellites, there is a little pie chart showing which of these 4 that they contribute to. And these satellites will start with launches in 2027, up to 2030, roughly, for the first of each series. Then we've also got the next generation of the existing Sentinels to come. Those are ones currently in the early phases of studies. And then we also have our Earth Explorers. And here, this goes back to the first set, which is Cryosat and Goche, which were the first ones to be launched. And many of those are still operational. And you can see what they all look at. So Cryosat is for the ice, Goche is for gravity and water. Then we have SMOS, which is for soil moisture and ocean salinity. Then Swarm, which is for the magnetic field. Aeolus, which just finished its operations last year and is now going forward into an operational version for Aeolus 2. EarthCare, which we only just launched 3 weeks ago. And then we have the ones coming up in the future. So Biomass should be launched at the end of this year. And then we've got Flex, Forum, Harmony, and then Earth Explorer 11 and 12. So this is just to give a bit of an overview of the breadth of the Earth observation program that we have and the various areas of Earth observation monitoring that they contribute to, and in particular for climate change. So thank you.
Thank you, Graeme. You have...
Yeah, very quick comment. So we make also a bit more lively the discussion here. So just to give you an example of the integration of the data for a service, we spoke about the wildfire. So you have the Meteosat is looking 36,000 kilometers, looking down. Then Graeme showed the second.
Maybe about the next 10 years, something?
Yeah, easy peasy.
Something.
Yeah, I mean, first I would like to respond or to comment on what was just said by my 2 colleagues from EUMETSAT and ESA. They were mentioning new satellites like MTG, the sounder of MTG, for example, or EPS second generation. And you mentioned that, yes, it will improve NWP. It will improve NWP if NWP centers are up to the challenge, because it's not bread and butter. And even if it's not as fancy as all the new satellites that we are talking about, it will be a lot of effort and a lot of work to make sure that we can exploit these satellites to their maximum extent. And over the next 10 years, I believe that the developments that we have invested in modeling and data simulation will be able to use all these satellite observations in more and more complex situations. 25 years ago, anything affected by clouds were discarded in NWP because we didn't know what to do with them, basically. And now we use satellite observations in cloudy conditions, rainy conditions, over sea ice, over land, and this will continue and needs a lot of development. Maybe the second aspect I want to mention is also that the context is also changing. There are not only institutional organizations providing data, but there is also the private sector providing data. So this is also something that NWP centers will have to take advantage of. I mentioned in my presentation that there was an initiative called Destination Earth. I don't think it's still a program, but it's about building a replica of the planet. So ultra high resolution modeling. We will need a lot of observations to initialize this, and the idea is to build twins. So in partnership actually with ESA and EUMETSAT, to build twins for climate adaptation and also for extreme events. Again, this is quite revolutionary because we are able to have models with a fidelity which has never been equaled before. But the main challenge or opportunity at the moment is, I think was mentioned by Paolo already, is to do with machine learning, which is coming into play at a very rapid pace. If we had had this discussion 3 years ago, I would have reported about the strategy of ECMWF, which was to use artificial intelligence for pre-processing observations, for the post-processing, for replacing big expensive bits of the code, of the numerical code like radiation scheme, with a neural net and so forth. But between then and now, some private companies have come up with not numerical forecast, but forecast models only based on artificial intelligence. And ECMWF has developed a new strategy very rapidly with the member states and in partnership also with EUMETSAT to build a system which is also what we call data-driven. So in a way, bye-bye Navier-Stokes equations. So are we there yet? No, because all these new models rely on reanalysis to initialize their system. And ERA 5 is at the heart. What the reanalysis I presented is at the heart of this. But what will be the future in 10 years is very, very difficult. What will be the requirements for the new HPC computer, the big computers that we are using to do numerical weather predictions? If we are just in need of a super number of GPUs, it's also hard. So it's a challenge and an opportunity. And maybe I will stop there, and perhaps we will discuss more the role of you and the journalists in this story.
Yeah, that's quite interesting, because I saw on the ECMWF side already you are experimenting. Also, you can see the charts, the weather charts with artificial intelligence. So it's already an ongoing process, right? Okay. Yeah, then we ask Christina KÖPKEN-WATTS. She is at the WOD, that's the German Weather Service. And yeah, you are a very authoritative voice for forecasts and warnings in Germany. And yeah, how do you see the future from your point of view?
Okay, thank you very much. Yeah. Actually, before turning to that of actual forecasts and maybe nowcasting developments, I would just add or reinforce what Jean-Noël just said. This development with artificial intelligence used in different contexts really along the value chain, NWP is really massive at the moment. It's going on at the European Centre, it's going on at all the national weather services, and it's changing the way we do things, and it's going to change some workflows as well. So at the moment, there's parallel exploitation of using these approaches from observation processing through to data assimilation, numerical modeling, as Jean-Noël described. If we have very much faster models, we can run a lot more ensembles. Don't know how far you are aware that we also don't only produce one forecast, we try to assess the probability of a certain event occurring by running a large number of different forecasts with slightly different initial conditions and setups to see how likely a certain event is. And there, faster models based on artificial intelligence may allow us to run vastly increased numbers and to provide more accurate probabilities. And then we've also got a lot of post-processing adaptation to local conditions, which will take AI methods into account. So it is at the moment really exciting and in a way also frightening, because it changes a lot of what we do. And as Jean-Noël described, it's quite hard to really see which direction it is going and where to best invest most effort at the moment. But now to your question on the forecasting.
Yeah.
So nowcasting has, or the short range forecasting, I see two main development areas. One is very much focused on the extreme events to get better there. And that satellite data will be really important in providing additional information on atmospheric stability by measuring in many different layers, basically, through different frequencies. The system Arctic weather satellite and maybe feeding into a constellation of small satellites will be important by providing humidity information, especially with very high time resolution, also in cloudy conditions. That will help us, again, to get the environment right for highly convective developments. And a second branch, which is increasingly important with large projects actually running at the Weather Service, is the renewable energies that I was also mentioning as an example in the presentation, where we really focus on getting forecasts for wind at wind hub level better. The radiation is a big focus to really support first the planning for renewable energies, but then also stability of the nets and how they are set up. That's important.
And what do you think about the warning management? Because extreme weather events are evolving, and we had yesterday and day before and tomorrow again here in Germany. Therefore, I was very busy for predicting where it will be really intense from the thunderstorms. What do you think about the warnings in the future? Because often people say, yeah, we get too much warnings. And do you thinking about changing the warning system? And will this also benefit from new data from satellites, maybe?
I mean, that's a very important point you address, because warning is really not easy. A warning is, every person has got a different need for certain warnings or level, because the damage and the risk is different for individual people, for businesses, depending on their area. So the warnings probably will evolve in two directions. One is go for more automation and maybe also more individually tailored warnings, maybe through web-based services, etc. But the other component is that there's very strong interaction with especially emergency services and first responders to provide really personal advice. And I think that will remain important. And that actually has intensified as a consequence of the extreme weather situations we see, that there's very intense discussion and really very, basically the weather forecasters are available directly for discussion on the situation with the people. The third branch is in development, at least in Germany, that there will be, certain preparation time, of course, basically a central portal for natural risks and hazards, which basically regroups warnings and also then links to more specific information.
So you can combine the different threats together in your service.
Yeah, well, it's basically providing a central access portal or platform for different threat risks like flooding, avalanches, fires, weather forecasts and hazards, so that it's easier for the public to really access the information.
Yeah, this is very important for people who are working in TV stations and so on, who are making the forecasts for the audience, and to tell people what is going on and warn them, because also we are on TV, we are the people who warn the people. It's not always about nice weather events. It's more and more about extreme weather events. So it's very important.
Yeah, and the role of communication is really increasing, and it's increasingly important to well communicate what a risk means, what the probabilities are, especially the communication of how to deal with probabilistic forecasts. That is not an easy concept, and there I think also more interaction with you as a community is necessary, how to best transmit this information.
You want to?
Just to give an idea, we recently ran a socioeconomic analysis for IO's Sterna that was previously mentioned. When we speak about warnings, usually we speak about big storms and flooding, and the economic value for the 30 countries we represent is between 6 and 7 billion per year. Just to give a measure of what we are, of course, on top of that.
This will grow.
And we just speak about infrastructure and goods. We don't, of course, in those events, there's the tragedy of losing people, and we don't evaluate this because that's can't be evaluated. Just about infrastructure.
Thank you. The next point will be the sea surface temperatures, which I will mention here because we have since last year, since March 2023, we have an anomaly. It hasn't changed since then, and we have so many heat in the surface temperature. And this leads me to the question for Mr. TRAON. What about ocean prediction and ocean warnings? Because this warmth is linked to the weather we see everywhere, because all the moisture is coming down here and everywhere on the planet. We have everywhere floods, and this is, I think, a very interesting and important point.
Yes, indeed. As you see, I mean, we have seen extreme in the ocean. I mean, last year, I mean, extreme record in sea surface temperature globally, Atlantic, Mediterranean Sea, all these marine heat waves and so on, with many damaging effects on ecosystem, which means that we need also to really improve our capability to monitor and predict them. So on what we see in a 10 years, I mean, for the ocean, is really to improve the capability, in particular, to better describe at finer scale, in particular for the coastal zone. Because coastal zone, we know that all the economic issues, the hazard warning are for the coastal zone. So this is where we are moving towards much higher resolution for describing the coastal zone. We also are the same as for the weather forecasting, are moving towards the ensemble approach to better characterize error and probabilistic forecasting that is needed for many of the applications. I would like also to mention something specific for biology, because marine biology is essential. I mean, as you know, for many issues related to the protection of the ocean, there is this new international treaty on biodiversity beyond national jurisdiction, which is really a major achievement at international level to take action to better protect the ocean through the development of marine protected areas and so on. But we will need tools to assess how well these marine protected areas are working, which also mean a simulation tool. I mean, we mentioned digital twin ocean and digital twin activities and so on. And this really calls for advanced capability for modeling and prediction on prediction for the biology. Of course, for doing that, we need more satellite observation. That's in particular when we go to final scale. I mean, that's I gave the example of the SWOT satellite, which is a research mission today, but we are working with ESA on European Commission for the next generation of Sentinel-3 next generation for topography, which will have wide swath capability. So we'll be able to really better observe the ocean at fine scale and then be able to constrain model at higher resolutions that are needed for application, in particular for the coastal. For biology, it's the same. Biology, we need better ocean color satellites. I mean, in particular on spectral characteristic, more frequent observation as well validating and constraining the model.
And also for plastics, it's very important to track.
It's very important to track plastic. Once again, plastic is more a long problem initially, but then we need to take action just to reduce. But then you need to understand where the plastic goes, and for that you need a very precise occurrence and so on. I wanted also to mention also how the ocean community is working. I mean, towards developing new capability worldwide for ocean prediction. So we have this major United Nations Ocean Decade of Ocean Science, which is ongoing up to 2030. And as part of this major initiative at UN, so we are working together to set up an international framework for ocean prediction. This is part of what we call a decade collaborative center of ocean prediction, which is led by Mercator-Ocean International, but really to agree on all countries to develop common capabilities, in particular for the coastal zone, and to really making sure that everyone in the world has a system which is state of the art, and which is making the best use of satellites. So we are forgot to mention one thing important, that we, of course, we need to improve on the satellite. That's we need to have similar effort for the ocean, for the in situ observation, because that's really something which is we cannot see with satellite. I mean, it's a bit different for the atmosphere. I mean, we really need observation in the ocean interior. So I mentioned this Argo program. We are working on the evolution of this program to go deeper to the ocean, up to 6,000 meters. And we know that we have heat, which is stored at really those depths. We need to understand how much heat will go in the ocean. This is critical for climate and so on, and for also for the biology and biochemistry. Or maybe last point, and I will be done. Just because my colleague mentioned several times artificial intelligence, machine learning, the same issue for the ocean. It's a bit different because it's less observed on some, but this is also a revolution in the way we can improve and develop our forecast.
So, okay, thank you. So, Cyrille Honoré from WMO, the Secretary General of the United Nations launched an action to equip all member states with early warning systems. Can you tell us something about this?
Right. Thank you. And first of all, let me thank you for this invitation, and also congratulate for the excellent presentations we've seen this morning. And I will definitely go on the far right of the value chain. We'd rather talk the value cycle because there are feedback loops, of course. And Phil Evans, in his opening remarks, was absolutely right. We see massive investments, scientific, technical developments here, moving forwards, state-of-the-art developments here. And still, we are today in a situation where worldwide, barely 50% of countries have, let's say, proper early warning systems in place. And so Gutierrez, the UN Secretary, was right. We absolutely need to correct the situation as part of climate adaptation. We are almost off track with mitigation, and we already see impacts from the climate change. So we need to put more efforts on adaptation, and early warning is really part of proven measures that support the process. And so this initiative, if there was, I had a couple of slides to share with the audience, maybe that could be displayed. This initiative has one specificity. It's a UN initiative, which WMO is co-leading with the United Nations Office for Disaster Risk Reduction, and organized across different pillars that you would find in any classical disaster risk reduction literature, right? And we want definitely with our partners, you see ITU and IFRC are specifically in charge of respective pillars, which makes sense for the audience we have today, right? Dissemination and communication of the warning is an essential part of the process. We can have the perfect forecast. We can have really accurate data and information. If this is not communicated, if this is not understood, no decision will be taken that will help saving lives. And so this is kind of ambitious. The timeline that was given is 2027, which more or less anticipates the Sendai framework for disaster risk reduction targets by 3 years. We know it's going to be a challenge, but we also believe that a lot can be done, and a lot is taking place. We are receiving support, political support at the highest level in a number of countries. The resources needed to do that are coming. Well, resource mobilization is a process, you know, everybody knows it takes some time, but we're receiving support. And we also need to acknowledge that there is a lot going on, right? And there are a lot of people, development agencies, a variety of organizations that support capacity development in a number of countries.
It's also a point of education, because you can have best warnings, and if the people don't get the information or don't understand it, you have a problem, right?
Absolutely, and this is why the interest of the initiative is joining forces between partners that come from pretty different horizons. And the social science component needs to be integrated here, right? You guys know, right? When you tell the people, oh, tomorrow we expect 125 millimeters of rainfall, doesn't mean anything for most of the people, right?
You have always to explain what it is and what the effects are.
Absolutely.
Yeah.
And in this area, we need to improve significantly in a number of places by combining this information, by training the people as well. The human component here is also important in terms of how people understand the message and how they can react to that, and to have the proper institutional and operational arrangements that will support the process, right? If the Met agencies or whoever electing authorities related to different hazards are not properly connected to disaster management agencies, media, and the rest of it, the information will not fly to the people. And there are very different situations across the world. Here in Europe, connectivity is good, right? It's not the case everywhere, right? So we need to have those processes in place by which information can reach the people at risk, the local governments, all the people, first responders for preparedness, everything, in a way that is actionable to them. And it needs to build on different channels of communication by which people can also check what the information is, because this is important. They need to trust.
Yeah.
No action can be taken if there is no trust. And you, with the presenters, you're the face that tell people this information. They will cross-check. There is a variety of sources of information today with social media, with a variety of things, and people need to cross-check and have the trust in what they should do and to protect their livelihoods and their lives as well.
Yeah, I think that's the most important point in weather forecasting. As I said before, it's more important to say what is going on in different extreme weather events and how they will arrive in which region. And this is important, and the people must understand what is going on there, and therefore they must trust weather forecast, of course. So you're of course right in that point. I would ask you a question about, yeah, we talked about it already, but how do you see the weather presenters? It's for all the roundtable here. How do you see the role of weather presenters in the next years? Or maybe what could we change to be better? It's also an important question what we always ask us. I don't know who wants to start. Maybe do you want to start?
I can start briefly because as part of the Copernicus Climate Change Service, which you will hear more about tomorrow, being able to communicate on the state of the climate, what's happening on extreme events, put them into context. You will have an increasingly important role. There is a risk that we are talking to ourselves when we issue these plots and produce papers, and we are all concerned about climate change, and in fact nobody cares. I mean, I shouldn't say that, but we saw at the last European elections, for example, that
No, you're absolutely right.
the European Green Deal may, there is a risk that it goes at the back of the queue in terms of priority. So we need to really keep telling people what's happening. We need to be scientifically, as I mentioned, watertight, because it's a prerequisite to provide the information that you can use safely. So there is a lot of work in terms of satellite observations, reprocessing of satellites for climate monitoring, anything, and what has been talked about. But your role is actually fundamental to be able to communicate to lay persons about what it means. And this is your job. It's probably not our job to do it. So we really rely on you to do this. And this will go, it will become increasingly important because there is really a threat that climate change, after all, is not a priority anymore.
Yeah. I think it's already changed the communication. I use a lot of this climate bulletins, and it's very, it's just visible what is happening there or what has happened in the last month. And also you can talk about the weather, what has happened, and the anomaly of the temperature, so people get it directly. And it looks also like our weather charts, so you can show it to the people. And before we had this instrument, it was more difficult to communicate about it. But with this bulletins, it was very easy. And for us, I think I can talk for everybody here, for the weather forecasters, it's very important that we get data, not just data in columns, also in graphics, and that we can use it very fast, because in a newsroom, we have no time to verify every data. It must be finished. So we take this and put it on screen. If it works like this, and it works like this, then it's very good. Then we are fast and can communicate very easy about this. Christina?
Just maybe a little down, I fully support. And one important component, I think, when talking about climate is really to translate it, as you said before, what does it mean on a daily basis for the people? What is the implication of 180 millimeters of precipitation, or what is the implication? I mean, you showed nice examples of the glaciers melting. Mm-hmm. How will it impact? What may the world be like in 10, 20, 30, 40 years? And what does it mean for the daily lives of people? And the second point I would like to add is, I mean, that goes beyond the community of just weather presenters, is to tread the fine line between stressing the urgency of the situation and action, but at the same time transmitting optimism that we can do it, so that we don't remain in a situation, oh, it's really difficult, but we have the means, we just need to act as a community in countries and worldwide to make the change happen.
This is quite complicated, because as a weather expert, you have 1 minute and 30 seconds for your weather forecast, and you have no chance to make a journalistic impact. So you are just showing your charts, and you can just maybe say a half sentence about the climate, what is crucial, and then you have to continue and you have to finish. Like here, we have a time schedule 1 minute and 30. If you have 1 minute and 40, then it gets complicated. And it's, on one hand, it's our job to communicate the facts. I think that's the most important thing for us weather forecasters and presenters. But the journalists must do the other part of the job with the optimism to stress out that it's positive, to have a positive communication about when we have less ICE cars outside, we have better air quality and so on. What do you think about this?
Yeah, I mean, that's what I meant. It goes beyond the community. There needs to be the interaction of this information with the other kind of topic areas in journalism and media to take this across.
One important aspect, I think, whether presented, you're already doing a lot of important work also for us. But one important message, I think, is the how to connect what is the final outcome, which is a warning, which is a weather prediction, to what is the work behind it. So a satellite, which costs a lot, has a lifetime of 10, 15 years, then you have to consider the planning, designing. So for a policymaker to take a decision on a satellite, it means putting investment on something where there's no political return, because the satellite will appear when probably the political cycle is already ended. So it's important to connect the value of what's happening in the weather, in the climate, with what is behind, what all these observations that are needed. I think this is important in many value chains. Just the last, Christina mentioned Earth quality. So we are launching this Sentinel-4 in our Meteorologist third generation, measuring nitrogen dioxide. Why is important nitrogen dioxide? No inflammations, respiratory system, etc. So making those links where the people, they clearly understand the value and why we need that measurement.
Yeah, that's the work for journalists. We are also journalists. We're not just meteorologists. But of course, when you have more time, then you can mention these points better in your work. So, okay, we have about 5 minutes about. We can take some questions from here and from the community maybe. So maybe we start with the community first. No, here? Okay, then yes, we have questions. Yes, please push the button there and we can hear you. Yeah, right. Thanks.
I will speak French. I'm Lynn René. I am journalist for radio and TV in Cameroon, in Central Africa. We were talking before about numerical weather predictions that will help us as presenters, weather presenters. I was very happy to see earlier a picture about early warning systems. And we were talking about communication and dissemination, and we were talking, we saw a man that was listening to a small radio. And in sub-Saharan Africa, in Central Africa, we have noticed that it is much more radio that is listened to when it comes to weather. Radio is still the first media. TV is there, of course. But if you look at the persons working in the sectors that are most impacted by climate change, like agriculture, because sub-Saharan Africa is still 70 to 80% agricultural region and area. And so you have people that outside in the field with the radio, they don't have a TV there. So I think it's much more important for this region, for sub-Saharan Africa, to have presentation through the radio and not TV. So I would like to know whether those numerical predictions also take into account the fact that we have presentations on the radio and not so only on TV. So
the risk communication about the risks, right? Okay.
Well, if I may, and thank you for the question. Well, NWP outputs, right? They are not tailored for a specific media, right? They are the fuel, the material from which you can analyze and that you can use for and create warning information. Then the dissemination, you're 100% right. We need to use multiple channels because not a single channel will reach everyone. And we need to adapt to that. So there are different ways, including some standards for communicating the warnings. That can be for any type of hazard, and that can be processed by any type of platform and media. As an example, You could see Amber Alerts, crawler messages on your TV screens. This can be done localized on radio to quick dissemination as well. So there are a variety of options. But in some cases, we also need to rely on the people, right? Because not everyone has access to digital information right away. And we need to use relays of information. That can be community leaders, can be faith-based organizations, whatever. But we need to find a way to make sure that all people at risk receive the proper information.
So
and this is important.
Everything. We should use everything, every channel to get the information to the.
Yeah, and if I may add, we could observe globally that there is a difference in connectivity and access to information, as an example, between women and men, right? And so we need to address that as well, because the impacts when we say that people are going out in the fields and what happens with people staying at home? Mobile phone ownership is also not evenly distributed. And so we need to take care of that as well, because obviously women and children are more impacted by a variety of hazards than men, globally speaking. So the inclusivity is also part of the concern that we need to address.
Yeah, there was,
Well, maybe it's not directly to the question, but going back to the initial discussion of the roundtable on the last question, I mean, I would like to maybe stress that in the future, I mean, this is a way to communicate, so whether on, to the general public and to speak more also on the ocean.
Already hotter, so you get more moisture and more violent storms. This is the combination. This is a very easy combination, and you don't even have to mention climate. Yeah, and it works already. Okay, so we are at the end. Unfortunately, I must say we have to stop here. You can go outside later and can talk, or the break later. Sorry for this. But I would say we can make a photo with all the participants and with who has made a talk here, and all other colleagues. Please, you can go outside, have something to eat or drink, and then we meet later again. Is this right, Grace? Do we have? Okay, I have a go. Then for the photo, please come to the stage.